Well, hello. My name is Nguyễn Hoàng Vũ. Okay, I am a student of Mechatronics K19, and today, on behalf of my team, I'm going to present you our mechanical design project, which is the T-shirt folding machine. Yes. So let's get to the PowerPoint. Okay, this is a much better view. Before anything, this is our team. Yes, we have been working this whole semester. We've been working very well. Yes, and I would like to give out a very special thank you to our instructor, Ahmad Young. Yes, thank you very much. Without you, we couldn't have done it. Sincerely, thank you. Okay, next, I'm going to run you through four parts today. First one is the introduction, yes. Second, we are going to talk about the mechanical design. This is very, very important. Next, we're going to talk about calculations so that the mechanical design can work. And finally, we are going to give out the conclusion and future developments, yes, that we want to do, but unfortunately, we couldn't have done it as of right now. Okay, so why a t-shirt folding machine? Let's talk about the t-shirts first. Now, I want you to look down. Are you wearing a t-shirt right now? Yeah, everybody know what a t-shirt is. Everybody have worn one before. Yes, it is very casual. You wear it every day. You see this everywhere. You see this. Kids wears it. Adults wears it. Most of most of all, the younger generation is wearing it like every day because it is comfortable. It is like so it's so easy to to wear, and it is fashionable too, right? So as you can see, the demand for selling t-shirts has been growing like really high recently. Yes, because I know a lot about fashion. Not a lot would be overstretched, but I've been looking into fashion for a while, and as we are as the how do I say it? The state of fashion right now is like casual, like what is the word? Minimalism. Yes. So just wear something simple. It's something that will aid you in like to get through the suffocating like life. Yes. And therefore, uh, we to in order to ship out to sell more products and okay, we'll get to that later. To ship our products, we need to fold them together, right? That is one of the reasons. Other from that, there's a lot of reasons why you need to fold the t-shirts, like, and don't I don't think that my mother told me to fold my clothes like for nothing. There's a reason for them, big reason. Okay, so I'm sure that you have been seeing this like videos like a lot. I saw this personally. I saw it on TikTok first. All right, it was like a life hack. I think it is fascinating. Yes, you can fold the clothes with just some cardboard and duct tape. It is really useful. Okay, so based on this design, based on this principle of folding a t-shirt, we thought to ourselves, could we have make a machine using this principle? Yes. And would it be possible? Like, do we really need one? Like, I think that, yeah, we of course need one because look at the industrial size, okay? You cannot have like 200 workers just like folding clothes. That would be impossible. That would be wasting of uh, manual labor, right? So you need a folding t-shirt folding machine, at least for t-shirt selling for the t-shirt selling industry. Yes. So that is why we came up with our machine. Yes, you can see here, this is our first pictures. I'm going to talk about it right now. And yes, we are really proud of it. Okay, so let's talk about the history. It's back in the 80s, there have been people, scientists, engineers working on this in Italy. Okay, I'm not gonna say their name, I might like ruin it. Uh, Also, they have not only been able to fold the t-shirt, folding clothes, they have been able to package it too, right? So these things have been developed like before the year 2000, like before I was born. So like we are not new to this like area of research. So you could say that we have a lot of uh, how do we say, former instructor. Like have we borrow a lot of ideas from from other manufacturers, right? So still using these symbols like uh, cardboard thingy, right? We have designed it our own t-shirts folding machine. Yes. Okay, this is one of our uh, competitors. I don't think we could say competitor because no way I could beat these guys, right? Yes, but we do beat them in like some in some areas. Okay, let's talk about this one first. This one is the Mikio 8450, right? This is the one that struck with me the most. I really love this one. It is compact, flexible, and really low on power consumption. The negative uh, aspect of this machine in particular is it is quite slow, and it does not, therefore, it does not produce enough like product in time comparing to the others. Like this one, it is high compact and high productivity. The folding wings here move very quickly, right? Also, this one, the FX25, it is really fascinating because it uses HMI display, this little display right here. So the worker can control how they want to use the machine. Yes, and this is something that we've been wanting to do. Okay, so now we are going to go through the main part of our presentation, the mechanical design. We have borrowed this design, a sort of a table with four sides. Like we are cutting out these two parts and revealing the motor. Oh no, not the motor. The cylinders and the actuator underneath on how to move these foldable wings. All right. As you can see, this is our specs right here. Okay, these numbers are individual parts. The first one is uh, the frame body. The second one and the third one. Okay, we will go through that later. Okay, right here. The first one is the frame. You can see here, and this tabletop even this is part of the frame. The top folder is this orange color, orange. Yes, it's not too orange. Okay, the left folder and the right folder here we use like they are practically the same. Just place we just use it twice to place it on both sides of the machine, and then we have the final folder which is these two. All right, and there are other components like the hinge, the cylinder, and the folding mechanism, which we spend a lot of time like researching and coming up with this one. Okay, so we are going to talk about that. Right, so with 9 parts we have here, we separate them into 3 parts. Okay, 3 categories. The frame of the machines, which is just this one. Okay, it is really complex because you can see here we cut out a lot of hoses so the machine could work without interfering with the frame. All right. Second part is the wings, the main part that is contacting with our products, aka the t-shirt, and the actuator is the driving factor to move our foldable wings. Okay, simple, right? So we put on here a demonstration of our t-shirt. As you can see, a worker or anyone, you, me, anyone, will put the t-shirts onto this desktop, right? and then they would use and then they would push a button, and this top folder will fold in, this one, the two side folder will fold in, and then the final will fold in, just like this, yeah, just like this, right? So easily to understand. Okay, so we separate the frame into three sections. Okay, you couldn't have seen it like so clear in this picture, but in here we separate them into three floors. The first floor, like I call it the tabletop before, right? We will hold the frame. This is the most like important one. It's highly precision so that it does not interfere with the t-shirts when it is folding. Okay. The second floor, this floor right here, is where the actuators are placed. As you can see, our folding mechanism, yes, and this small pocket over here is where we are going to store our electric circuits, yes. And the third floor is where the wiring for those pneumatic cylinders to be placed. So right here we're going to place a what is that, reservoir, right? And you know, what is it called, solenoid, yes, to control this pneumatic circuits. Okay, so let's talk about the folding wings. Actually, I have talked about this before. You can see there are 1, 2, 3, 4, 5 folders, which we designed it 3 of them. These two are the same, these two are the same. Okay, it's just being placed on the opposite side. Okay, we hold them together using the hinge. Okay, about the hinge, we will talk about that later. Now, this is the drawing of our foldables wings. Okay, this we didn't give out the correct dimensions because the machine is meant to like interchangeable. You could replace these folders to fit different types of t-shirt, different sizes that you want to fold. Okay, so this is just so. Okay, enough about these one. Oh, well, one more thing. The material that we decided to use is plastic, PVC plastic, because it is like friendly. So it is it could withstand a lot of forces. Okay, among these plastics, and it is also very safe for human contact. Right. About the hinge, we are using the torsion hinge, which have this design right here. At first, we wanted to use the button, but we've run into some problems because you know there is a lot of torsions going on when you fold using the actuator that we designed. So we swapped it out using this hinge. Okay, there is 3 parts of it. This right here is the steel hinge. Oh no, this is the moving hinge, the part that will be moving. Okay, this is the first part. This is the drawing for it. This is the steel hinge. This part will like stick into the frame of the machine, and it will stay there to stabilize the folding mechanism. This is its drawing, yes, and then combine it all together, we will have this whole product. Okay, this right here is the shaft to holding it, and this right here is the roller right here. No, not this one, right here. Okay. So now to our most anticipated part, we go to the actuator. Like if you remember, we've asked you a lot about how to move how to transport, how to transport this motion of moving a cylinder up and down into a a turning of the folding movement of the folder. Okay, so this is our design. So this is our cylinder. It will go up and down being controlled by the pneumatics mechanism. And we have here a slider which will move in and out. Okay, I'm going to show you this one so it is easier to see. Okay, this is our machine. Let's put this away for a moment. All right, let's put this one away too. Okay, you can see this is our finished kind of finished product. We have the reservoir here and some buttons, but for now let's hide all of them, revealing just the mechanism. Hide this one too. I'm hiding everything. Okay, so this is our mechanism and this is how it will move. As we pull this one up, okay, the slider will go inward, right, allowing this this piece of metal to move its head up a corner. As we continue to move it, it will go upward, pushing this folder to fold over from 0 degree at the end, at the start of the cylinder, to about 120 degrees. Okay, and it will fold our clothes perfectly if we maintain the speed of 40 meters a second. Oh really? No, 40 centimeters per second. Yes, I'm sorry, that's too quick. 40 centimeters a second is more reasonable. Okay, it takes about half a second for the cylinder to move up, right? So the rotational speed of this angle is about 240 degrees per second, right? And these other mechanism is using the same principle too. Okay, let me show you. Okay, let's actually pull this one down. Okay, now we move this one up. Right, as you can see, the same principle is used here too. Sorry, it's a little bit laggy. We have more than like how many, 700 parts and mates in this SolidWorks file, so it's a little bit laggy. Right, you can see it's still moving like smoothly in our test. Right, this one works too. Okay, this one worked very well. Just a little bit laggy. Okay, and the final one, this one gives us the most headache. So we actually need to like try to find a different angle so that, but at this stage we are the master of this mechanism, so we managed to like put it at a position which will still fold it up like this and pull it down with ease, okay, without interfering with the others mechanism before it. Right, so giving you a better look at this, we're using 2 Ps to connect the cylinder to this slider, to this rod, to this to the folder. We are using, this is the, I believe these M20 bolts and nuts and washer to hold these parts together, which is really sturdy, and you wouldn't be worrying about it breaking apart when it's operating. Okay, so you can see here we use this design to connect to our folder. Yes, don't have a lot to talk about this. These are just parts needed for the machine to work. Here's just connector. Right, so we spend a lot of time designing this piece This piece is actually inspired from the AT450 machines we talked about earlier. Yes, we each work the same principle. There are actually two cylinders, but we are only using one cylinder and a slider, which works like better, I think. Okay, now to the pneumatics control circuits, designed by my friend in the group. He is really good at designing these circuits, as you can see here. Okay, it is better written, better explained um, in the report that we are going to send you. So this is very simple, just the basics electric pneumatics circuits. This is this thing worked using the rhythm method, right? And we put in there a lot of other buttons. Like this one, we have the reset button, the start button, the stop, the basics, and the power switch. Sorry. And our our little spices. Okay, we have a pedal right here, not pedal. I'm sorry. Okay, so imagine like you are standing at the machine, you are standing on this side, and you are putting your uh, your t-shirts onto the surface. So your hand is busy, right? But your feet is not. So you step on the pedal, and then it will basically it is a second start button, right? So it is more productivity, which is always welcome. And now to our final part, the conclusion and our future developments that we will look into in others projects. Okay, the conclusion is our team has successfully calculated the mechanical design and the actuator. We are very proud of our actuator. Yes, the design is pretty much borrowed, but I think that the design is like pretty much it is pretty much perfected by the former goer. The calculation will be put really clearly in the report. The pneumatic design has been working very well, and the drawings and ideas are done pretty well too. Our drawbacks while doing this projects that we have failed to develop a packaging system. Well, on behalf of this, we think that we take advice from our instructors saying that maybe it is just best to just take out the final product on top of the desktop. So we might not be needing it, but we would love to develop it in the future. Okay, and yes, we still have to manually insert the t-shirt. Like there still have to be a worker standing there, putting the shirt on the desktop and then stepping on the pedal, right? So that is not fully automatic. We are at this step of like semi-automatic. For future development, we will uh, gradually switch to fully automatics, being able to just throw in the shirt, really wrinkle and stuff, and then getting out a product without a flaw. Using IoT to control the model remotely. Yes, it is really IoT has been booming lately. Everybody is every like every projects that I look into this, most of them use this IoT because it is amazing for developing your products. We are going to adding more functions like ironing or packaging. We are going to use sensor to count the number of products or using machine vision to check the forms, uh, check if there's any errors in the process, and then being able to control it, right? So that is going to be the end of our presentation. Thank you so much for listening. Uh, the experience of making this uh, t-shirt folding machine has been a really long journey for us. Thank you so much.